Okay, here I would like to present to you the midpoint theorem. So midpoint theorem, right? It says that if you have two triangles, PQR and PST, if point S, right, ST here, right, is drawn in such a way where this S, right, bisect PQ, so PS equal to QS, and this line ST bisect PR, right, where PT is equal to TR. Okay, if they bisect like that, right, these two lines are parallel, and this line QR, right, is equal to 2 times the length of ST. That is midpoint theorem. So today I'm going to prove to you why is this so. Okay, so to prove to you why is this so, you have to establish similar triangle here. So for similar triangle, in triangle PST, and my triangle PQR. My PS is equal to half of PQ. And my PT is equal to half of PR. And my angle, right? Angle SPT is equal to angle QPR, because they are the common angle. Therefore, by SAS, triangle PST is similar to triangle PQR. Okay, this is something we established. So my triangle PST is similar to triangle PQR. Okay, because they are similar. So because they are similar, these two angles will be the same angle, right? Since they are similar triangle. Since they are similar triangle, my angle PST will be equal to angle PQR. Since these two angles is the same, right? Therefore, these two lines must be parallel because corresponding angle. So by corresponding angle, ST is parallel to QR. So I've proven that they are parallel. Then your triangle PST, right? Your PS over your PQ will be equal to ST over your QR. So PS over my PQ, right, is 1 over 2. Earlier on, we established that because they are similar. Okay? So my ST equal to ST over QR is half, right? Therefore, 2ST is equal to QR. Therefore, QR is twice the length of ST. Yeah. Proven midpoint theorem. Oh, you understand now, midpoint theorem?
But then you can only apply this when like PS equals PQ equals like 2PS, right?
Because these two triangles, right, they are similar. This big triangle, the length is twice the
So
corresponding length.
does it only work if the
Only work
PQ
if
is
this
twice
this
of
mid. Only work if these two are midpoint.
you need two
Only work if
midpoints.
only work if S is the midpoint of PQ and T is the midpoint of PR. That's what
So
it meant by.
basically
That's why it's
in the
midpoint theorem.
in like two similar triangles, if I have two midpoints, then the line between the two midpoints will have the midpoint theorem.
Yep. If arranged in this order, in this structure, so
Okay.
midpoint theorem apply. This length here is twice of this. If this
Yeah.
point is the midpoint of PQ and this point is the midpoint of PR, that's midpoint theorem. That's what I'm trying to prove to you. And these two angles is the same because they are parallel. Because midpoint to midpoint, I draw a line. So these two lines are parallel.
Does it work the other way?
Yes, yeah, the reverse way also work.
So
If
like
these two lines are parallel, and this one is twice that of this, therefore this point must be the midpoint of this line, and this point is the midpoint of PR. The
okay.
reverse way also work.
Okay.
Okay, no question already
Nope.
for midpoint theorem.
Nope.
Okay, then we move on to do the question already. Okay, we move on to do the question. Okay.